It is very, very important question. It will come in the 4 marks. The question is, find the real constants a comma b so that the function f is given by f of x. For x less than 0, x greater than 0, the functions are sin x and x square plus a. For x is less than 1, x greater than 1, x square plus a and bx plus 3. For x is less than or equal to 3, x is greater than 0, bx plus 3 minus 3. The function is continuous function on R. And each and every value, the function is continuous. See here, when we take at x equal to 0, then these two functions are selected. When we can take at x equal to 1, we can choose these two functions. If at x equal to 3, we can choose these three functions, these two functions. See here, if we can choose at x equal to 0, the functions having only unknown value is a. When we can choose at x equal to 1, the unknown values are a and b. And at x equal to 3, the unknown value is only 1. So by observing that function, how we can choose the x values and how to get a and b values. Okay, if the function is continuous. Suppose we know that at x equal to 0, the function is continuous. It is continuous. Then what is the relation? Then it satisfies the relation limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. If we can take at x equal to 3, the function is continuous. Then limit x tends to 3 minus f of x is equal to limit x tends to 3 plus f of x. Why I am choosing these two values means in these two selection of the values, the unknown values are 1 only. If I can choose x equal to 1, the two are unknowns. So we can get the relation of a and b, but not the values of a, b. Okay, if by choosing of x equal to 0, what we are getting a value, that value substitute here, then we get b. It's also fine. But directly we can get for choosing of x equal to 0 and x equal to 3. For x equal to 0, we get a value. For x equal to 3, we get b value. Okay, that is the selection of the finding of a and b. Now, for case 1, at x equal to 0, the left hand limit in this as x tends to 0 minus, then x values are less than 0. So limit x tends to 0 minus f of x is equal to limit x tends to 0 minus, what is the x less than 0 relation is sin x. So here we can write sin x. Substitute 0, it is sin 0, value is 0. Next, take the right hand limit. That is x tends to 0 plus, then the x value is greater than 0. Limit x tends to 0 plus f of x is equal to limit x tends to 0 plus, what is x greater than 0 value? X square plus 1. X square plus a, not 1. X square plus a. 0 square plus a is 0. Sorry, a. F is continuous. At x equal to 0, then limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x. So it's 0 is equal to a. So a value is 0. This is the case 1. Next, we can take the case 2 relation. Case 2. at x equal to 3. Take the left hand limit. X tends to 3 minus, then x is less than 3. Limit x tends to 3 minus f of x is equal to limit x tends to 3 minus f of x value is 3 minus means this is bx plus 3, greater than 3 is minus 3. Bx plus 3. Substitute x is replaced with 3, 3b plus 3. And RHL at x tends to 3 plus, then x is greater than 3. Limit x tends to 3 plus f of x is equal to limit x tends to 3 plus minus 3 equal to minus 3. F is continuous at x equal to 3. So what is the relation? Then limit x tends to 3 minus f of x is equal to limit x tends to 3 plus f of x. F of 3 minus f of x is bx plus 3. It is equal to minus 3. That is
3bx.
3b. 3b plus 3 is equal to minus 3. So 3b equal to minus 3, it is minus 6. B equal to minus 6 by 3, it's minus 2. Therefore, A equal to 0, B equal to minus 2, then F is continuous. It is the solution. Show that f of x equal to set of cos ax minus cos bx by x square if x is not equal to 0, 1 by 2 into b square minus a square if x equal to 0, where a and b are real constant is continuous at 0. Solution. See here, at x equal to 0, it is a constant value. At x is not equal to 0, the function is cos c minus cos d form. First, we can take cos ax minus cos bx by x square can be converted into separate terms. We are using the formula of cos c minus cos d is equal to minus 2 sin c plus d by 2 c minus sin c minus d by 2. So here cos ax minus cos bx is equal to minus 2 sin of ax plus bx by 2 sin of ax minus bx by 2. That is nothing but minus 2 sin of a plus b by 2 into x sin of a minus b by 2 into x. So it is minus 2 sin of a plus b by 2 of x sin of a minus b by 2 of x whole by x square. So this is the simplification of the f of x. It is f of x at x is not equal to 0. And it is a continuous. It is a continuous at x equal to 0 means the limit values are equal and we can take the limit x tends to 0, f of x is equal to f of 0. Then f is continuous at x equal to 0. The relation of the continuous means limit x tends to 0, f of x equal to f of 0. Why we are taking 0 means here they have given the relation is not less than greater than relation. It is in equal not equal relation. So here clearly f of 0 is the 1 by 2 into b square minus a square. But we can calculate limit x tends to 0. The function is what is that? Okay, where a and b are real constants. We can take that is limit x tends to 0 f of x is equal to limit x tends to 0 f of x means minus 2 sine of a plus b by 2 into x sine of a minus b by 2 of x by x square. Minus 2 right outside, limit x tends to 0 sine a plus b by 2 of x by x. Okay. Here minus 2 right outside, limit x tends to 0 sine of a plus b by 2 of x by x. But what is x coefficient is there? That is comes in the denominator. So we can multiply and divide with a plus b by 2. And write the second function, that is limit x tends to 0 sine of a minus b by 2 into x by a minus b by 2 into x is multiply and divide with a minus b by 2x. So these two are get cancelled. We are getting the same term. But we know that sine or ax by ax limit x tends to 0 is the 1. So it is minus 2 into a plus b by 2 is a constant, a minus b by 2 is a constant. The remaining limit values are 1 into 1. So 1 to 1 to get cancelled. It is equal to minus of a square minus b square by 2 by multiplying with negative 1 by 2 into b square minus a square. This is clearly f of 0 value. Therefore, f is continuous.